why SystemVerilog is needed,
Okay.
and what's the main difference between the Verilog and SystemVerilog?
Yes. Okay. Actually, the main difference between Verilog and SystemVerilog means Verilog and SystemVerilog have their own pros and cons. But when it comes to the main advantages of coming to SystemVerilog or Verilog is hardware description language HDL. But SystemVerilog is HDL, which is nothing but HDL and HDL plus HDL. It is for description as well as verification. We can consider SystemVerilog in that particular manner. And one of the most advantage coming to SystemVerilog is memory. Static memory, we consider static memory in Verilog, but when it comes to SystemVerilog, we will consider dynamic memory. There are four types of arrays: static array, dynamic array, queue array, and associative array. We have these memories in SystemVerilog, but when it comes to Verilog, we have only static memory, which holds good for design part, but not for verification part. Ma'am. So for verification point of view, we will consider SystemVerilog, ma'am,
Hello.
and yes, ma'am.
You discussed about this static and the dynamic memory, right?
Yes, ma'am. Yes, ma'am.
What's the difference between them?
Yes, ma'am. Actually, the static memory we cannot overwrite them. It will be the constant throughout the compilation time, but we can change according to our memory specifications in dynamic memory now. um, and also during runtime static memory will be created now. During compilation time dynamic memory will be created.
Mm. So why the SystemVerilog needed? Continue with that.
Yes, ma'am. Actually, I have given two advantages over Verilog system Verilog. Third one is reusability, ma'am. And and also the main advantage is also coverage, ma'am. We will consider code coverage in Verilog, but when it comes to system Verilog, there will be functional coverage, ma'am. Uh, Functional coverage tells about the functionality of the design, whether the perfect design is correct or not.
Hari.
Yes, ma'am.
In Verilog also there is we have reusability. So why you said that in SystemVerilog we have reusability?
Yes, ma'am. Actually, we have uh, uh, we have randomization in Verilog as well as in system. We have randomization in system Verilog, and unsigned random is possible in system Verilog. In that particular way, the reusability is way more high than in Verilog.
What? Unsigned? Unsigned?
Yes, ma'am. Unsigned random. There are dollar random and dollar u random.
So what they will help in that?
Sorry, ma'am.
What they will help in that?
Actually, yes, ma'am. When it comes to random variable, there is a chance that one variable may be the repetition not covering the entire range, but when it comes to unsigned random as well as a random, there is high chance that the total range will be covered, ma'am. All random variables, all full range will be covered. In that particular way, code reliability and reusability will be.
Can you repeat that? Can you repeat that?
Okay, ma'am. Actually, uh, there will be when coming from Verilog to system Verilog, reusability is also definitely an advantage, because you asked the reusability is also possible in Verilog, but why we are coming to system Verilog means random we use rand keyword for random for generation of random variables in destination. and dollar $u_random and dollar $random for two keywords for randomizing the variable. Those are for random variables and unset random variables respectively. And yeah, ma'am, there is chance that repetition of values without considering next another variable is also possible thing in rand keyword. Um, when it comes to system Verilog, it covers entire range from unsigned integer. There is high chance that repetition is not allowed, and it covers entire. Will be
Okay, so you want to say that with RAND we can cover more numbers and constraints, right?
yes, ma'am.
It can be more specific, I think. Taking the
Okay,
RAND
ma'am.
and RAND.
No. Actually, sorry, ma'am. Sorry for disturbing.
Yeah,
Uh,
okay.
we will consider OOPS concept, ma'am. Question very well.
Yeah.
Hello.
Yes, the main I'm
Sorry,
saying that the main feature you for
unable to hear you.
hello.
Yes, ma'am. Right now,
I'm saying the main feature you forgot about the OOPS concept.
that's what I remember.
The main reason why we use the system Verilog is that on.
It's often concept
What do you know about the OOPS concept?
OOPS and
What do you know about the OOPS concept?
okay. Actually, in OOPS concept, we will consider class, object, and the handles and many things. Why we consider means for creating we should create objects. We create objects using new keywords in system Verilog, and object is nothing but instance of class and system Verilog. But when it comes to class is a sorry before considering object, I should tell about class. Class is a basic building block, and object is instance of class, and the point is nothing but it will point towards object ma'am. Before we implementing before we use the new constructor, the pointer will be handled pointer point pointer will be pointing towards a null object, but after using the new constructor, the pointer will be pointed towards an object.
Mm.
we will um, uh, we will uh, we will create a handle by using class name after the some variable. We can consider VLSI V1. VLSI is nothing but class object. V1 is nothing but handler pointing
Mm.
towards the class.
Mm. Hello.
Yes,
Yeah. How we create the instance?
how we create
How we create the class in the system Verilog?
by giving some variable name after that we will consider handle name. Before if we if we give before if we consider one name and if we give before the visual, it will become abstract class. Visual keyword. Visual keyword is used to achieve polymorphism in Verilog. Polymorphism but ability of an object to take on many forms.
If I want to use the use some class in another class, how we can do that?
Yes,
There is a
ma'am.
concept. What that concept called?
Class inside another class, we will consider Virtual class.
No, I'm talking about the OOPS concept. Okay.
Instead
Have you
keyword, ma'am. Instead keyword we can use.
have you heard about the inheritance?
Yes, extend inheritance.
There are two things, the parent class and the child class. Yes. So how we use the child class and parent class? Do you know the syntax?
Yes, ma'am. I know the syntax and actually for super keyword we used to call the functionalities of parent class inside child class. To call the
Structure.
properties of parent class inside child class, we use super keyword.
No, no. We use the extend something,
Extend
you know.
extend keyword is to create the child class from parent class.
No, no. To create an object and class, we use the new operator. And to call the constructor, we use the super keyword.
Yes, ma'am. Super keyword is to call the properties of parent class inside child class.
Yeah, yeah, yeah. And to
Extend keyword is
extend it,
to
to use the we extend the child class
child class properties from
parent.
parent
Yes. Okay.
class. Correct, ma'am? Or,
So I must say that you must focus on the OOPS concept. The inheritance is the most important topic. Industry, the inheritance is only used there all the time. In UVM also, the OOPS concept are the main.
I have learned the definitions of keywords and inheritance basic concepts I know, ma'am. But yeah, ma'am. Suddenly, actually the first thing I want to tell is the advantage of coming to SystemVerilog or Verilog is that I remember a lot. I will definitely remember those.
The difference between the RAN and RAN-C.
A RAN keyword is RAN keyword we will, as I said before, to generate the random variable. But RAN C keyword, the generating random variable is some event constraint.
Okay. What are the constraints in SE?
Constraint in S3 is
What are the use of the
voice.
hello? I'm saying that what are the use of the constraints in SystemVerilog?
Constraint,
In you can
constraint,
2 to 3 minutes. I'm not.
suddenly the voice.
I'm saying you can take 2 to 3 minutes for thinking. I am okay with it.
Okay, ma'am. Actually, I would like to tell implication operators to explain about the constraint. Verilog. We want our if we consider the implementation operator, if we want our request and grant to be in should be high in same clock cycle, we can in that particular way consistently use it. And or after two clock cycles, my grant should be high before the request is high. Or continuously for three clock cycles, it should be high. Non-continuously three clock cycles, it should be high.
So you want to say that in randomization, we use the constraints
Yes.
to constrain the statements or to use them with conditions.
With keyword we use them to consider the inline constraint. Randomizing as well as constraints in same line we can do is
Yeah,
we can do with keyword.
correct.
Sorry, ma'am.
That's correct.
Okay, ma'am.
So, do you know the difference between the pre-randomized and post-randomized function?
Okay, ma'am. Pre-randomization, pre-randomization means we will use our rand keyword for randomization as I said before. Pre-randomization is nothing but we need some variable for generating some random variables. We will do the pre-randomization. Actually, rand keyword is by default. We cannot change in between. But pre-rand and post-rand we can change in between by giving some constraints. Before randomization is considered pre-rand, and after randomization is considered post-rand.
So pre-randomized is called before the randomization happens, and you can use it to prepare or set up the things before the random values are assigned. Okay.
That's what I'm referring.
Hmm. Hello. Have you listened my question?
Ma'am, I thought I said I mean, before randomization is nothing but pre-randomization for setting up the uh, what what value should be randomized. And after randomization, nothing but post randomization. It is nothing but making sure that the required values are getting randomized.
So, what are the threads in system Verilog?
Sorry, ma'am, what are the
Threads.
sorry,
What
ma'am.
are the threads in system Verilog?
Threads in system log. Okay, ma'am. Actually, we can there is a concept called verbosity in UVM for split statements and
Wait, wait. Hello.
what, ma'am? Hello.
What you said?
There is a concept called verbosity in UVM.
What concept?
Verbosity. I mean, actually,
Verbosity.
yes, ma'am, verbosity.
Okay.
The, what I want to tell is, in verbosity, we will consider higher, the one which is higher will not display them. I mean, we want our statements not to be displayed. For suppose if we consider 1,000 statements,
Yeah,
let's
yeah.
say,
You are talking about the UVM low, UVM high.
yes, ma'am, UVM low, UVM high, UVM medium.
Connected like threads. diversity, how they
Sorry, ma'am.
I'm saying that how Verilog and UVM diversity, how they are related.
Yes, ma'am. Actually, that's what I'm trying to refer to. Let's say I have 1,000 display statements, and let's say in 777 line, let's say I don't want that particular statement to be displayed, not to be displayed. So we should consider all those 777 statements, and then we should do that. But when it comes to it is one of the major traits, ma'am. It's one of the major traits, but when it comes to major verbosity, sorry, verbosity UVM, we can give reports like UVM low, UVM full. That means if we consider UVM low, higher order will not be printed. I mean UVM full, UVM high like that will not be printed. So in that particular way, we can use it.
That they are related. I am talking about the system.
And as per my knowledge, ma'am, the one of the threats in SystemVerilog is we use concepts, ma'am. It will become somewhat complex, ma'am, because we should we should call our functions and classes in very precise manner. So it is somewhat complex.
To know the fork join statement.
What, ma'am?
Do you know about hello? Do you know about the fork join? Fork join?
Yes, ma'am. What kind?
It's fine.
Both join operation uh, will be in concurrent manner. Concurrently, the operation will be executed. Uh, it is similar to initial begin, but let's say after 5 nano, initially my a value is 0. After 5 nanoseconds, my a value is 1. And after considering 5 nanoseconds, that is after total 10 nanoseconds, my a value is 1. But if we consider fourth join, initially A is 1, and after 5 nanoseconds, A is 0. And then here the main difference comes. In initial begin, after 10 nanoseconds, I want my data is high, it will come out like that. But when it comes to fourth join, again at the 5 nanoseconds itself, A should be 0 or 1 according to we have given.
Okay, let me show you the code. I am able to see the speed.
Again, it's blank.
So, can you please tell me the output of this?
Yes. For the first one, that A value will be at session time, A will be displayed, B will
Okay,
be displayed.
my
Sorry, ma'am.
disturbing. I'm audible.
No, ma'am. Anyway, it's
I'm saying that can you speak a bit louder?
yes, ma'am. Yes, ma'am. I will. Yes, ma'am. Can you hear me, ma'am, right now?
Yes, please speak a bit louder. And there are some disturbance in mic.
Okay, ma'am. Am I audible right now?
Yes, yes. Okay. And
Uh, in first one, you consider fourth join just as fourth join at zero simulation time. A will be displayed, B will be displayed. Hello?
what you said? What will be the output?
A will be displayed, B will be displayed at zero simulation time.
Will be.
Hello?
Yes, please. Can you repeat?
A value will be displayed as well as B value will be displayed in
Okay, okay. Then what when will be the C value will be displayed?
C value will be displayed immediately after displaying A value and B value.
Okay. So the answer is the A and B in the parallel and C only after the both are done. You were
Yes,
correct. Yes.
yes, ma'am.
Okay. Now next.
Okay. The second one at starting from zero simulation time, after 5 time units, A will be displayed.
Okay.
And again from starting from zero simulation time, after 10 units, B will be displayed.
Okay.
And accordingly, C will be displayed. Join any keyword before will be disabled, after that C will be displayed.
So A, B, C.
Sorry, ma'am.
You want to say the serial number is A and then B, then C.
Uh, no, ma'am. C, A, B.
2 to 3 minutes and think again.
Yes, ma'am. Output will be A, B, C.
Don't you think that first the A will be printed at 5 nanoseconds and then C immediately after A and then B later.
Yes, ma'am. Perfect.
Can you give me the explanation why?
Actually, both join any keyword means before will be displayed and after that C will be displayed.
A, C, and then B.
Uh, join any fork and join any block will be active now. That is for sure.
Okay.
Yes, ma'am. At at 5 units A will be displayed and 10 units B will be displayed. he will be displayed after that. After those two active, and then only he will be active. From my knowledge.
Hello, Hari.
Yes, ma'am, yes, ma'am.
What do you understand?
Hello, ma'am. Can you hear me, ma'am?
Yes. What do you understand by the thread?
Thread. Acha,
Yes.
thread. 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 System threads is nothing but we consider fork and join, ma'am, as per the example you given.
By using the fork join or fork join any or fork join none, we are creating a thread
Okay, okay,
in a parent class. So after the answer of the fork join any will be the after the A executed at the 5 nanosecond, the parent, the child class will be ended that only, and then parent class C will be printed, and then the child class B will be printed.
okay, okay.
Because the parent has to wait until the first child is done. The first done is A at the T is equal to 5. Only then C will be executed, and then the thread will again executed.
Okay, okay.
Do you understand?
Yes, ma'am.
So in fork join any, parent resumes after the first child finishes.
That's it.
Yeah.
In fork join none, parent value will be executed after two child class are executed.
Can you repeat that?
Uh, when it comes to fork join none, ma'am,
Yes.
uh, uh, first parent class will be executed.
Okay.
After that, two child class will be executed.
So what will be the output?
C, A, B.
Okay, that's correct. The parent does not wait at all, and all child threads kept running in the background. Okay.
Now I remember the
Yeah. So the fourth one.
wait for means one week high simulation time will be executed. I think.
Um, can you repeat?
Uh,
Yes, you can take 2-3 minutes. I'm okay with it.
okay. For fourth one, I'm telling you.
Yeah.
Same as third one, join none. As I said, parent class won't wait for child class. to execute. So at disable fork means firstly parent class will be executed, and that is at till 10 nanoseconds task 1 will be created. After 12 nanoseconds it will not wait, none, nothing will be executed. Fork will be disabled.
Can you explain me why that happened?
Uh, join and as we discussed before, parent class won't wait for completing the tail classes. But here dollar display is not showing.
So according to me, you can briefly and by in simple words, you can say that at 12 nanosecond, disable fork will disable the
It
fork
is
time.
yes,
Ah, so the time 10 nanosecond, task one will be executed and then disable fork at
fork,
12 nanosecond, it will disable it.
fork will be disabled after 12 nanoseconds. Till then, task one will be enabled.
Yeah. So that would be a correct and short and crisp explanation.
Uh, Sixth one,
Yes, fifth one.
okay. Parent class waits for the child class
Okay.
to get executed. That is after completion of child class only, parent class will be executed.
So what will be the output?
A, B, C.
Okay, that's correct. So you understood all.
That's the rest.
That's great. Hence, in system Verilog,
What
region, regions.
region?
Yes.
Yes. The execution of the text bench in SystemVerilog will be reactive region and non-blocking region and then active region. Sorry, hello.
Okay. Um, the system Verilog simulation regions I am talking about.
Simulation region will be in reactive region. Reactive region and non-blocking regions. Simulation will take place.
Okay, leave it. What do you understand by the regions in system Verilog?
We want our execution not to be. Uh, I mean, latches should not be inferred, ma'am, in our in our design. So we make sure that it
Wait, wait. You talked about the latches do not insert, right?
yes,
What do you mean by that?
by not using non-blocking assignments, there are chances of inferring latches because they one of the ports may not be driven to the test bench from DUT. So it should not. We want our code not to be happen like that. So latches should not be inferred in our code. We make sure that we make sure by considering the simulation in non-blocking region.
Where did you understand? Like, where did you read about it?
Uh,
The insert latches thing.
Actually, when I'm studying the advantages of non-blocking by usage of non-blocking assignments, I came to know that we can overcome the we can overcome the resonant condition by using a non-blocking assignment. We will get resonant condition by in latches referring. So I try to connect with this one. So, as per my knowledge, correct.
On the system Verilog, you will get an error. Uh, I think you should try. I think you should try it. Some examples, then you will get the latch inferred error. That would make you understanding more better.
Okay.
Yeah. Yeah, so let's continue on the regions. System Verilog, scheduling semantics, we can also say that.
Oh,
Do you know about the NBA region? NBA region.
excellent. MBA region is nothing but non-blocking assignment region. Non-blocking assignment event region. MBA. Hello.
So I was talking about the what do you understand with the regions?
Actually, talking about the flow of regions.
Yeah, the design takes some time cycles to respond to the driver input to produce the output. Oh.
Active region, inactive region, pre-NBA region, NBA region. Uh, these are the regions, ma'am, for driving or input to output.
Yeah. Okay.
So we want, in NBA region, the particular simulation technique.
Do you know about the errors in system Verilog?
Errors,
Errors.
arrays. Okay, okay. Yes, ma'am.
The
There are four
packed
types of.
and unpacked. You should
Uh,
in okay. So what you will say in the
what?
packed and unpacked errors.
Yes, ma'am. Before identifier, after data type and before identifier name, we will consider tagged array. After identifier, we will consider untagged array. When I am saying red
Mhm.
320 mem 720, 320 is nothing but tagged array and 720 is nothing but untagged array.
Hello.
Hello, ma'am.
Yes, I'm saying that will you show the syntax for them by writing?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yes. Okay. I think you must detail this topic, the unpack arrays.
Sorry, ma'am.
Hello? I'm audible.
Yes, ma'am. Right now you're audible.
I'm saying that you must read the unpack and packed array topic in more detailed way. Then you must be know about more new. Then in next mock interview, I will take them.
I should thoroughly go through the array.
Yes.
No, actually, okay. If I can prolong them, factory and factory, if I can expand them, I think I know the concept of array. Hello, ma'am. Hello, hello, ma'am. Hello,
Hello.
hello, ma'am.
Hello.
Yes, ma'am. Hello.
I'm saying that you
Yeah, yeah, tell me.
know,
Ma'am, you are completely unaudible. Unable.
hello.
Yes, ma'am. Yes, ma'am. Right now, I'm audible.
Talking about activity, unpack and the topic in more detail.
Okay, ma'am.
Okay, so next time when we will take the mock interview, I will ask you some more detailed question on that topic.
Actually, I think I can extend this array, ma'am. Actually, okay, ma'am. I will go thoroughly again and I will make sure I prepare.
Okay. So, do you know the hierarchy of the UVM?
Yes, ma'am.
Can you draw and explain me?
Okay, ma'am. Ma'am, are you able to see?
Yes, can you kept it near the camera? Okay. Can you explain them?
Okay, ma'am. Actually, there are three types of classes in UVM, ma'am. UVM components, UVM objects, and UVM transactions. And when it comes to UVM components are used to make test bench components. UVM components includes UVM environment and agent. Agent is also called universal verification component. If the agent is active, it will sequence driver and monitor the sequence items. But
What is
in
the sequence item?
sequence item, data items, actually, sequence items means data, map.
Okay. Data, information or data?
Data information.
Okay.
If
Okay.
agent is passive, it will only do monitor, ma'am. It will not sequence and drive them.
Okay.
And when it comes to the
This
other
is the use of driver.
driver routes the data from it routes the data. I mean, it takes the data information from sequencer to se- sequence items from sequencer to driver.
Duty? Where is the duty?
No, sorry, sequence item to DUT. Driver routes the data from sequencer to DUT.
Okay.
Sorry.
Yes. Then continue.
Here, when it comes to other UVM transactions used to generate stimulus. UVM, yeah, UVM transactions, it UVM sequence items comes under UVM transactions.
Okay. So what is the use of the monitor and scoreboard?
Okay. Scoreboard, monitor and scoreboard means monitor, it keeps on monitoring the sequence item whether the data is being driven to DUT or not. Scoreboard means data, it will be displayed, ma'am. On the scoreboard, data will be displayed, ma'am. Whether our data information we got or correct or not, we may be able to know from scoreboard.
And do you know about the phases in UVM?
Yes, ma'am.
What are they?
UVM phases are yeah, was to use it for synchronization between test bench components, ma'am. And okay, the types of UVM means run phase, extract phase, end of elaboration, start of simulation, and, build phase, connect phase.
Okay. So what is the use of build and build phase?
Build phase, that is where the DUT components is being driven to the test bench before assignment.
No. So what is the use of the main phase? Okay. Um, Please read about it. And in the next class,
Okay, build phase we do instantiation by other components.
yeah, we build the connections,
We
and
build the connection with
yes, in the main phase, we do the main work.
we do the main by module
Yes.
inputs and outputs. We will do the main test.
Mm, okay.
Connecting the components, I do in build phase. Okay.
Okay, that's all from my side. That's all from my side. Do you want to ask some question?
I mean, I will improve my knowledge in array concept. Man. Next time, I will make sure that I am good at it.
Yes, yes. And I will ask you the tougher question from that topic.
In which area I should improve so that I may be able to crack the interview.
Um, you have to improve in the system dialog and UVM whole thing from every topic to have the detailed knowledge in every topic. Mainly focusing, I think you should firstly focus on the threads.
Okay.
Okay, then the packed and unpacked arrays. Uh, that would be the main topics from system.
Okay.
Then gain some more knowledge in the about the UVM phases. Okay, so, thank you. Bye.
Thank you. Thank you for sharing the knowledge.
Okay.